Welcome back to my YouTube channel. Today we will discuss about the theorem. For any positive integer n, limit x tends to a, x raised to n minus a raised to n by x minus a equals n a raised to n minus 1. Now we will discuss about the proof of this theorem. X raised to n minus a raised to n by x minus a. Let us divide x raised to n minus a raised to n by x minus a. We know how to divide two numbers. 15 by 3. How will we divide 15 by 3? We know that. Find the number which has to be multiplied with 3 to get 50. The number which has to be multiplied with 3 to get 15. 15 divided by 3 gives, we know 3 into 5 is 15. So the quotient is 5. Now multiply these two numbers. 3 5s are 15. Next step to perform the subtraction. Here we give 0. This is how we divide two numbers. Is it clear? Similarly, x raised to n minus a raised to n by x minus a. Here, let us find the number which has to be multiplied with x to get x raised to n. Is it clear? Find the number which has to be multiplied with x to get x raised to n. That number is nothing but x raised to n minus 1. X raised to n equals x into x raised to n minus 1. Let us check. X means x raised to 1 into x raised to n minus 1. Here the base values are same, x. So we can add the power value. So this is in the form of a raised to m into a raised to n. That is equal to a raised to m plus n. X raised to 1 into x raised to n minus 1 equal to x raised to 1 plus n minus 1. Here minus 1 and plus 1 get cancelled. We get x raised to n. So we have to multiply x with x raised to n minus 1. We got x raised to n. So this is our quotient. X raised to n minus 1. What is the next step? Multiply with these two. X minus a into x raised to n minus 1. X minus a into x raised to n minus 1. First we multiply x into x minus 1. X raised to n minus 1. Minus next a into x raised to n minus 1. X is nothing but x raised to 1. These bases are same, so we add the powers. This is in the form of a raised to m into a raised to n equals a raised to m plus n. Here x raised to 1 plus n minus 1 minus a into x raised to n minus 1. Minus 1 plus 1 get cancelled. We got x raised to n minus a x raised to n minus 1. Multiply with, similar to this, multiply with x minus a and x raised to n minus 1 we give x raised to n minus a x raised to n minus 1. Is it clear? So x raised to n minus 1 is multiplied with x minus a. First time we got it as x raised to n minus a x raised to n minus 1. Now perform the subtraction. These two are same with opposite sign. This minus this gives negative. This minus of minus is positive. So a x raised to n minus 1 minus a raised to n. Now a x raised to n minus 1 minus a raised to n by x minus a. We have to divide these two. Again we have to find the number which has to be multiplied with x to get a x raised to n minus 1. That number is nothing but a into x raised to n minus 2. A into x raised to n minus 2 is multiplied with x to get a into x raised to n minus 1. We have to check. First write a here. X means x raised to 1. X raised to 1 into x raised to n minus 2 This is in the form of a raised to m into a raised to n, that is equal to a raised to m plus n. So a into x raised to 1 plus n minus 2. 1 minus 2 is minus 1. So a into x raised to n minus 1. So this is the number which has to be multiplied with the x to get a into x raised to n minus 1. So this is the quotient plus a into x raised to n minus 2. Again multiplied with these two. A into x raised to n minus 2 into x. What is that? A into x raised to n minus 1. A into x raised to n minus 1. Minus a into x raised to n minus 2. These two a's we got a square into x raised to n minus 2. So minus this minus sign write it here. Again we have to perform the subtraction. Already this here positive sign, this minus this gives negative. Here negative sign is there, then minus of minus gives positive. Then these two get cancelled. Then plus a square x raised to n minus 2 minus a raised to n. Again we have to perform the division. A square x raised to n minus 2 minus a raised to n by x minus a. Then find the number which has to be multiplied with x to get a square x raised to n minus 2. That number is nothing but a square x raised to n minus 3. So you have to check a square into x means x raised to 1 into x raised to n minus 3. First a square write it first, then write the remaining. A raised to m into a raised to n equals a raised to m plus n. 1 plus n minus 3. 1 plus n minus 3. 1 minus 3 gives minus 2. So a square into x raised to n minus 2. So that this number a square into x raised to n minus 3 is multiplied with x to get a square x raised to n minus 2. Then the quotient we got it as a square into x raised to n minus 3. Then again we multiply with these two. A square x raised to n minus 3 into x gives a square x raised to n minus 2 minus a square x raised to n minus 3 into minus a gives minus a cube x raised to n minus 3. Then perform the subtraction. This we got minus, here minus of minus gives plus. These two get cancelled, then got a cube x raised to minus 3 minus a raised to a. Like this way, we continue the process, we will reach to this particular value. A raised to n minus 2 into x square minus a raised to a. Again, we have to find the number which has to be multiplied with x to get a raised to n minus 2 into x square. Here, a raised to 1 into x raised to n minus 1, power of a is 1. A square into x raised to n minus 2, power of a is 2. A raised to n. So, the power of whatever be the power value of a, that has to be subtracted from the power of x. A raised to 1 minus x raised to n minus 1. A raised to 1, a raised to 1 into x raised to n minus the power of a. A square into x raised to n minus 2. Here the power of a is 2. That is to be subtracted from the power of x. Here a raised to n minus 2 into x raised to n minus n minus 2. The power of a is n minus 2. That power is subtracted from the power of x. Is it clear? So this can be written as a raised to n minus 2 into x raised to n minus n. Minus n and plus n get cancelled. Minus of minus 2 gives 2. So x square. This x square can be written as x into x. One x is combined with the s, a raised to n minus 2. So the number which has to be multiplied with x to get x square into a minus 2 is x into a raised to n minus 2. So the number which has to be multiplied with the x to get x square into a raised to n minus 2 is nothing but x into a raised to n minus 2. So this is the quotient here, x into a raised to n minus 2. Next step, multiply with these two. That gives a raised to n minus 2 into x into x. That gives x square into a raised to n minus 2 minus a raised to n minus 2 into x into a. So a raised to n minus 2 into a gives a raised to n minus 2 a raised to 1. So 1 plus n minus 2. So a raised to n minus 1 into x. So subtract these two. So this is minus. This minus sign will change it as positive. These two get cancelled. So positive a raised to n minus 1 into x minus a raised to a. Again we have to perform the division. Let us find the number which has to be multiplied with x to get a raised to n minus 1 into x. Which value is multiplied with x to gives a raised to n minus 1 into x? That value is nothing but a raised to n minus 1. We have to multiply a raised to n minus 1 to x gives a raised to n minus 1 into x. So the quotient is a raised to n minus 1. Then multiply with these two. So a raised to n minus 1 into x minus a into a raised to n minus 1. A means a raised to 1 into a raised to n minus 1 gives a raised to 1 plus n minus 1. 1 and minus 1 get cancelled. Then gives a raised to n. Is it clear? A raised to n minus 1 into x minus a. First, a raised to n minus 1 is multiplied with x, and second, a raised to n minus 1 is multiplied with the minus a. A raised to n minus 1 into x minus a into a raised to n minus 1. This a is nothing but a raised to 1. So, a raised to n minus 1 into x minus a raised to 1 plus n minus 1. This minus 1 plus 1 get cancelled. Then a raised to n minus 1 into x minus a raised to n. This is in the form of a raised to m into a raised to n equals a raised to m plus n. Here a raised to 1 into a raised to n minus 1. Here m is 1 and n is n minus 1. So m plus n gives 1 plus n minus 1. 1 and minus 1 get cancelled. So a raised to, we got a raised to n. So a raised to n minus 1 into x minus a raised to n. Then again perform the subtraction. This minus this. This sign will change it as minus. This minus of minus gives plus. Both of them are cancelled. We got 0. So limit x tends to a, x raised to n minus a raised to n by x minus a. We have to find this. So we got the quotient as x raised to n minus 1 plus a into x raised to n minus 2 plus a square into x raised to n minus 3 plus etc. plus a raised to n minus 2 into x plus a raised to n minus 1. Is it clear? Here we got the quotient as this. X raised to n minus a raised to n by x minus a equals this value. Then find the limit of that value. Limit x tends to a, x raised to n minus a raised to n by x minus a is equal to limit of x. Limit x tends to a, x raised to n minus 1 plus a, x raised to n minus 2 plus etc. plus a raised to n minus 1. Here limit of this. Then apply the limits separately, sum of the limits. Is it clear? We can apply here the algebra of limits. Limit x tends to a, x raised to n minus 1 plus limit x tends to a into x raised to n minus 2 plus etc. plus limit x tends to a raised to n minus 1. Here what is limit x tends to a, x raised to n minus 1? Apply the limit directly. A raised to n minus 1 plus a into a raised to n minus 2 plus etc. plus a raised to n minus 1. A raised to n minus, what is a here? A means a raised to 1 into a raised to n minus 2. A raised to m into a raised to n equals a raised to m plus n. So a raised to 1 plus n minus 2, that is equal to a raised to n minus 1. This is a raised to 2 plus n minus 3. 2 minus 3 gives minus 1. So a raised to n minus 1, etc. How many times? N times. So 2 plus 2 plus 2 plus 2 plus 2. This is 5 times 2. What is 5 times 2 gives 10. This is 5 times we add 2, that we write it as 5 times 2. 5 into 2, that is equal to 10. Here we add a raised to n minus 1 n times, that is equal to n times a raised to n minus 1. So limit x approaching to a, x raised to n minus a raised to n by x minus a equal to n a raised to n minus 1. This is our theorem, hence the proof. Here one example is there. Limit z tends to 1, z raised to 1 by 3 minus 1 by z raised to 1 by 6 minus 1. To apply this formula here, this is in the form of limit x tends to x raised to n minus a raised to n by x minus a, that is equal to n a raised to n minus 1. So we should have to change this question into the form of our theorem. How to change? This is in the form of z raised to 1 by 3 minus 1 by z minus 1, or z raised to 1 by 2 1 by 6 minus 1 by z minus 1. convert the question into the form of this and this. Then only we have to apply our theorem. So our question is z raised to 1 by 3 minus 1 by z raised to 1 by 6 minus 1. To convert this question into the form of x raised to n minus a raised to n by x minus a, we have to multiply the numerator and denominator by z minus 1. Is it clear? Because we want to convert the question into the form of this. So we have to multiply the numerator and denominator by z minus 1. So limit z approaching to 1, z raised to 1, this z minus 1, we write it here and this goes to here. Is it clear? Then this becomes limit z approaching to 1, z raised to 1 by 3 minus 1 by z minus 1 into this z minus 1 by z raised to 1 by 6 minus 1. Is it clear? Then limit z approaching to 1, z raised to 1 by 3 minus 1 by z minus 1. This can be written as 1 by z raised to 1 by 6 by z minus 1. Is it clear? Both of them are equal. Then apply the limit separately. Limit z approaching to 1, z raised to 1 by 3 minus 1 by z minus 1 by limit z approaching to 1, z raised to 1 by 6 minus 1 by z minus 1. Is it clear? Then what is 1 here? Z raised to 1 by 3 minus a raised 1 raised to 1 by 3 by z minus 1. The denominator as limit z approaching to 1, z raised to 1 by 6 minus 1 raised to 1 by 6 by z minus 1. Is it clear? What is our theorem? What is our theorem? Limit x approaching to a, x raised to n minus a raised to n by x minus a equal to n a raised to n minus. Limit x approaching to a, x raised to n minus a raised to n by x minus a is equal to n a raised to n minus 1. We convert our question is into the form of this. Here x raised to n minus a raised to n. Here z raised to 1 by 3. Limit z approaching to 1, z raised to 1 by 3 minus 1 divided by z minus 1 divided by limit z approaching to 1, z raised to 1 by 6 minus 1 divided by z minus 1. To convert this into the form of a theorem, we have to convert 1 into 1 raised to 1 by 3. This 1 into 1 raised to 1 by 6. Now this is in the form of a theorem. A raised to m into is x raised to n, limit x approaching to a, x raised to n minus a raised to n, both of them are equal, by x minus a. Denominator limit is z approaching to 1, z raised to 1 by 6 minus 1 raised to 1 by 6 by z minus 1. Now this is in the form of a theorem. Limit x approaching to a, x raised to n minus a raised to n by x minus a. Now this is in the form of a theorem. Is it clear? Now apply the value. What is the value? This becomes n a raised to n minus 1. N is 1 by 3, a is 1. Then n minus 1. N is 1 by 3 minus 1. Similarly here 1 by 6 into 1 raised to 1 by 6 minus 1. So 1 by 3 by 1 by 6. So 1 by 3 into reciprocal 3 by 1. Sorry, 6 by 1. That is equal to 3 and 6 get cancelled. Then 2. We got 2. 2 is the answer. Is it clear? Thank you.